And good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. And thank you for your patience and me trying to figure out what's going on here. But okay, so I have quite a few questions that came in by request. So I am going to start with those. And let's see here. This is from section 9.3. Number 12. It says, hang on here, let's move that over there. It says, simplify the radical expression. The variable represents a positive real number. So that means we don't need to worry about absolute value bars or anything. The original expression is negative the seventh root of 256 t to the sixth power. So the first thing I'm going to do is take 256 and break it down and write it in prime factored form. 256 is even, so 2 goes into it 128 times. So 256 is 2 times 128. 128 is 2 times 64. Oops, 64. 64 is 8 times 8. So what have I got? I've got 2 times 2, and the 8 would be 2 times 2 times 2, and the second 8 would be 2 times 2 times 2. So I've got what? 2 to the 8th power. Okay? Now, I'm going to take this, and I'm going to rewrite it as negative the 7th root of 2 to the 7th power times 2 to the 1 power times t to the 6th power. Why did I separate it as 2 to the 7th times 2 to the 1? Because the nth root of a to the n is a when a is positive. What? In other words, these two things undo each other. Now, I've got this negative sign here that's outside. The 7th root of 2 to the 7th power is a 2 on the outside. Nothing else comes out. So now I've got negative 2 times the 7th root of 2t to the 6th power. And there's your final answer. Any questions on that problem before we go on? All right, let's take a look at number 14 from that same section. Now, I'm not sure the person that asked about this, they have it right. So, but they ask for it. We'll take a look at it. Simplify the radical expression. We have the 6th root of, let's see, 3y to the 12th over 64. Okay, I could rewrite that as the 6th root of 3y, oops, hang on here, 3y to the 12th over the 6th root of 64. But let's take 64 and break it down. 8 times 8, 2 times 2 times 2, 2 times 2 times 2 to the 6th power. So now I've got the 6th root of 3y to the 12th over the 6th root of 2 to the 6th power. In the numerator, so up here, let's see here. The 3 is going to stay inside, but this, the 6th root of y to the 12th would be y squared on the outside. Left inside is the 6th root of 3. Okay, so far? In the denominator, the 6th root of 2 to the 6th would be 2. So there's the final answer. Okay. Any questions about that? Now, one thing I noticed, for instance, the person that asked about this, their answer was like that. And that is not incorrect. That is right. But typically what math people do is they'll put the radical stuff all the way to the right and the non-radical stuff first. So that's the answer that the author is showing is this. This is also correct, but it's just not the proper way they tend to do things. Okay, that takes care of that set of questions. We're going to move on to another person's questions here. So give me just a minute to reset this and find that assignment. Okay, there and there. This is also in 9.3. Turn my phone off here. Sorry about that. Let's see, number 9. Okay, so 9.3, number 9. It says, simplify the radical expression. All variables represent positive real numbers. And we have the square root of 448 a cubed b to the 5th. All right, so first of all, let's take 448 and break it down. That's 2 times 224, which is 2 times 2 times 112, which is 2 times 2 times 2 times 56, which is 2 times 2 times 2 times 7 times 8, which is 2 times 2 times 2 times 7 times 2 times 2 times 2, which is 2 to the 6th power times 7. Okay, any questions there? All right, so now I'm going to rewrite this radical. My index is a 2, so I want my exponents to be 2's or multiples of 2 or leftovers. 2 to the 6th, 6 is a multiple of 2. 7 is going to be a leftover. A cubed I'm going to write as a squared times a to the 1st power. B to the 5th I'm going to write as b to the 4th times b to the 1st power. So all my exponents are 2's or multiples of 2 or leftovers. Okay, for instance, these are all to the 1 power. Now we're going to go through and take the square root of each piece. The square root of 2 to the 6th would be 2 to the 3rd. Is everybody okay where we got the 2 to the 3rd?
Yeah.
All right, this stays inside. A squared, square root would be a. This stays inside. B to the 4th square root would be b squared, and this stays inside. So then I've got what? The square root of 7ab. I'm going to take that and multiply it out. So my final answer is going to be 8ab squared times the square root of 7ab. Any questions about that?
Where did you get the 8? What did you multiply to get the 8?
2 cubed.
Oh, yeah, got it.
Righty?
Yeah.
Not a problem. Okay, we're going to look at number 10 now. Let's see here. So this is 9.3, number 10. Simplify the radical. The variable represents a positive real number. We have 6 times the cube root of negative 81 a cubed. All right. I'm going to take negative 81 and write it as negative 1 times 81, and then negative 1 times 9 times 9, negative 1 times 3 times 3 times 3 times 3, negative 1 times 3 to the 4th. Okay, so I factored out the negative 1 and then did the prime factorization of 81. Okay, now my index is a 3, so I want cubes or leftovers. So I'm going to get 6 cube roots of negative 1 times 3 cubed times 3 times a cubed. Let me write that a little bit clearer. Okay, so this got a negative 1. All right. Any questions where I got the stuff that's inside the radicand? Okay, here we go. So I've got a 6 outside. What's the cube root of -1?
That would just be -1, right?
Correct. Good. What's the cube root of 3 cubed?
I want to say 3.
Then do, because it is. Because the exponent and the index undo each other, all right? This is not going anywhere. What's the cube root of a cubed?
A.
Yeah, what, you Canadian? All right, cube root of, sorry, 3. Okay, so what have I got? I've got -18a cube roots of 3. All righty. Any questions there before we go on? Okay, this is 9.3, number 14. Simplify the radical expression. The variable represents a positive real number. We have the 6th root of 5y to the 12th over 64. Okay. 64 is 8 times 8 is 2 times 2 times 2 times 2 times 2 times 2 is 2 to the 6th power. So I'm going to take this and I'm going to break it apart into a numerator and a denominator. In the numerator, I can't do anything with a 5, but what's the 6th root of y to the 12th? That would be y to the
Second.
okay, and then I've got the 6th root of 5 left over. And down here, what's the 6th root of 2 to the 6th?
2.
And there we go. Okay. Questions? Going on. 9.3, number 23. Simplify the expression if possible. All variables represent positive real numbers. If the expression cannot be simplified, enter the given expression. So if you can't do anything to it, just leave it alone. And in fact, we can do something to it. All right, we have the 4th root of 432 p to the 8th q to the 2nd. 432 is 2 times 216, which is 2 times 2 times 108, which is 2 times 2 times 54, which is 2 times 2 times, what is it, 9 times 6? 9 times 6, 2 times 2 times 3 times 3 times 3 times 2, 2 cubed, 3 cubed. Something's not right here, so hang on. I made a mistake. Let's see. Ah, I see what happened right here. There should have been another 2 that came out. This would be 2 times 54. So basically, yeah, I lost a 2 in the process. That's what I get for trying to hurry, because I've got lots of questions people ask and I want to get through all of your questions, but I need to slow down. Okay, so the 4th root of 2 to the 4th times 3 cubed times p to the 8th times q squared. Okay, what's the 4th root of 2 to the 4th? That's a 2 on the outside. What's the 4th root of 3 cubed? Can't do anything to it, stuck inside. What's the 4th root of p to the 8th? P squared, outside. What's the 4th root of q squared? Can't do anything with it, stuck inside. 4th root of 27q squared. And don't forget to put that 4 index on your answer. Okay, we've got one more person's questions here. So let me get there. Okay. 40 times 75. There. 9.3. Number 10. Is that right? 9.3. Number 10. Okay. This is another case of where they've got the right answer, but maybe they got help and they're not sure how. But we'll take a look. 9.3, number 10. And this says simplify the radical expression. The variable represents a positive real number. 2 times the cube root of negative 81a cubed. All right. Negative 81 is negative 1 times 81 is negative 1 times 9 times 9 is negative 1 times 3 times 3 times 3 times 3 is negative 1 times 3 to the 4th power, which I could write as negative 1 times 3 to the 3rd times 3 to the 1 power. So what I've got, I'm going to rewrite this. I've got 2 times the cube root of negative 1 times 3 cubed times 3 times a cubed. So outside I've got a 2. What's the cube root of negative 1? We had that before. That's negative 1. What's the cube root of 3 cubed? That's 3. This is stuck inside. The cube root of a cubed is a. So what have I got left over? The cube root of 3 inside. So I've got negative 6a cube roots of 3. Any questions there? All right, our last one coming up. This is 9.3, number 12. Simplify the radical expression. The variable represents a positive real number. Negative the 7th root of 256 t to the 6th. Okay, 256 is 2 times 128, is 2 times 2 times 64, is 2 times 2 times 8 times 8, is 2 times 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 2, which is 2 to the 8th power, or 2 to the 7th power times 2 to the 1 power. Again, I went to the 7th power in leftovers. So rewriting this, I get negative the 7th root of 2 to the 7th times 2 to the 1 times t to the 6th. Well, the only thing I can take out of there is this, 2 to the 7th. That's going to be a 2 outside. We'll bring that negative sign down. 7th root of 2t to the 6th. So negative 2, 7th roots of 2t to the 6th power. And there you have it, folks. And now we're going to go on to the next section, which is also the last section that we're going to be looking at in this chapter. So over the weekend, you'll be doing 9.5 and the chapter review. Just a reminder, there's no class on Monday. It's a holiday. What is it, President's Day? Yes. So there'll be no Zoom meetings, no office hours. I'll be hiding off the map somewhere. But anyway, so Tuesday, we'll come back and do the chapter 9 review session. And then Wednesday, during class time, or well, whenever Wednesday, you'll take your test, okay? But no class on Monday. All right, let's get started here. Section 9.5. So we're going to look at some new equations, a new idea, and that is we're going to have an equation that has a radical in it. For instance, let's say we've got the square root of the quantity x minus 10 equals 1. If we have an equation with one term that's a radical, just like with absolute value equations, we want to isolate that single radical term. In this case, it already is. Now we want to square both entire sides. On the left side, the square root of x minus 10 squared is going to be x minus 10. So again, the implied 2 index and the 2 exponent undo each other, giving us just the radicand inside. And on the right side, 1 squared is 1. Any questions about what I just did there? All right, so now I'll add 10 to both sides, x equals 11. I'm going to check my work, so I'm going to put that right there. And I'm going to take the square root of 11 minus 10 equals 1. The square root of 1 equals 1. 1 equals 1, and it checks. So we're good to go on that. Any questions? All right, let's take a look at another example. We have a radical, the square root of 6x plus 1 equals 5. Again, we have a single radical. It's already isolated. We're going to square both sides of the equation. So I get 6x plus 1 equals 25. I'll subtract 1 from both sides. 6x equals 24. Divide both sides by 6, and x equals 4. Let's check our work. We have the square root of 6 times 4 plus 1 equals 5. The square root of 24 plus 1 equals 5. The square root of 25 equals 5. 5 equals 5, so it checks. So the answer is correct. Doing okay? How about this one? The square root of 3x plus 5 equals 2. Now, the plus 5 is not inside the radical.
Oh,
Question? No? Okay. So I want to isolate that radical term. So my first move is going to be to subtract 5 from both sides of the equation. So now I've isolated the radical. Okay. Now I'm going to square both sides. And I get 3x equals 3x equals -3 times -3 is +9. Then I'm going to divide both sides by 3, so x equals 3. Let's check our work. The square root of 3 times 3 plus 5 equals 2. The square root of 9 plus 5 equals 2. 3 plus 5 equals 2. 8 equals 2. So this x equals 3 is what's called an extraneous solution. Let's see, extraneous. I got to look that up here. Solution, okay? Now, when we square both sides of an equation, sometimes we get a solution that is invalid. So, but I believe what WebAssign will ask you to do is they'll ask you to solve it, check your work, and then you'd say, oh, this is an extraneous solution, and it doesn't work, okay? Now, I want to point out something. Let's go back here. Before we squared both sides, we had this. We're taking an even root. Recall the restrictions. You can't take an even root of a negative number. And when you do take an even root of a non-negative number, you can't get a negative answer. So right here, we're already in trouble. So right there, we could see that, oh, there's no solution. However, WebAssign wants you to go in and find that solution and then say it doesn't work. So, okay, just to clarify that. All righty, let's see here. Let's take a look at this one. The cube root of 12m plus 4 equals 4. So again, we have a radical. It's been isolated. So now what are we going to do to both sides of the equation?
square it.
No. Let me ask you a question. Does anybody know the story of Noah's Ark?
Mhm.
Do you know what the units of measurement were that Noah used to build the ark?
Mhm.
What is it? What were the units?
It was cubits. right?
Cubits, right, which is the distance from your elbow to your fingertip. Cubit. Why do I tell that story? Because that's the answer to what we need to do next. We need to cube it.
So we put the entire equation to the power of whatever is the
Yes,
index.
because you got to undo the index. Yep. If
Hmm.
that had been a 4, we'd have raised both sides to the 4th power. A 6, both sides to the 6th power. But in this case, it's a 3, so we're going to cube it. So on the
Right.
left side, we get 12m plus 4. On the right side, we get, what is that, 64? Okay. So now we're going to subtract 4 from both sides. 12m equals 60. Divide both sides by 12, m equals 5. Let's check our work. Let's see, the cube root of 60 plus 4, the cube root of 64, 4 equals 4, it checks, so m equals 5. All right with that? Okay, now let's take a look at, let's see, how are we doing? Let's take a look at this one. I have the square root of the quantity m plus 4 equals the square root of the quantity 2m minus 5. So now I have 2 radicals in the same equation. And just like absolute value equations, where if we had 2 of them, we wanted to separate them, same thing here. We want them on different sides of the equation, and they are. So now I'm going to square both sides since both of them have an index of a 2. On the left side, I get m plus 4. On the right side, I get 2m minus 5. I'm going to solve for m on the right side. So I'm going to subtract m. 4 equals m minus 5. Add 5. 9 equals m. Let's check our work here. Let's see. The square root of 9 plus 4 equals the square root of 2 times 9 minus 5. The square root of 13 equals the square root of 18 minus 5. The square root of 13 equals the square root of 13. Well, the square root of 13 is going to give me some decimal approximation on my calculator, but I do know this. I know the square root of 13 equals the square root of 13 regardless of what number it is. So it checks. My solution is correct. Okay. Now we're going to look at some formulas.
Quick question though.
Yes.
What if the indexes on the problem are not the same?
Then
Not
let's hope
done.
we're in a Math 141 class. Yeah. But I mean, there are things we might be able to do, but we in this class won't have to deal with that.
I
So
see.
you'll be able to sleep tonight knowing that. All right. We've got a formula. D equals 1.4 square roots of h, and we are to solve this thing for h. It says solve each equation for the specified variable or expression. Okay. Now, there is just one term that contains a radical, the 1.4 square root of h, because the 1.4 is all part of that same term. I have a couple of options. I can square both sides and then get rid of that 1.4 thing, or I can get rid of it to start with. Either way, we're going to get the same ultimate answer. What would you like to do? Leave it or get rid of it first?
I'd say get rid of it.
Okay, then we'll get rid of it first. So we're going to divide both sides by 1.4. Okay. So now we're going to square both sides. So I get d squared over, let's see, 1.4 squared, I believe that's 1.96, 1.4 squared, yes. So 1.96, and that's h. So we've solved for h. Any questions on that problem? Tell you what, let's go back and do it the other way just to show what that would look like. So let's move that over here. We'll say for h, and we'll write this thing again. So now we'd square both sides. On the right side, I'm going to get 1.4 the quantity squared, the square root of h, the quantity squared. So I get d squared equals 1.96h. Divide both sides by 1.96. Bada boom, bada bing. And there we go. Because again, here you have a product raised to a power, so you square each factor of the product. So you still get that 1.96. Okay, we good to go on to another example? D equals the cube root of 12v over pi, and we're going to solve for v. V is locked up inside of the cube root. There's only one radical term, and that's the cube root there. So we're going to cube both sides. So we get d cubed equals 12v over pi. I'm going to multiply both sides by pi. So we get pi d cubed equals 12v. I'll divide both sides by 12, and v equals pi d cubed over 12. Any questions there? Okay, let's take a look at this problem. Let's see here. Where did it go? 2 square roots of x equals the square root of 5x minus 16. We've got two radical terms. They're isolated, so we'll square both sides. On the right side, I'm going to get 5x minus 16. Be careful. What am I going to get on the left side?
4x.
Excellent. Yes, because the 2 is going to get squared and the square root of x is going to get squared. So I'm going to get 4x, not 2x. Good job. Let's see. We'll subtract 5x from both sides. Negative x equals negative 16. Divide by negative 1. X equals 16. Let's see. 2 times the square root of 16 equals the square root of 5 times 16 minus 16, which is 2 times 4 equals the square root of 80 minus 16. 8 equals the square root of 64. 8 equals 8, so it checks. Okay, let's see here. How about this one? It says, let h of a equal the fourth root of a plus 11 minus the fourth root of 2a plus 6. Find all values of a for which h of a equals 0. Now, at first, this thing may look awfully complicated, but let's break it down here. This is going to go in place of that. So that's going to give us 0 equals the fourth root of a plus 11 minus the fourth root of 2a plus 6. We have two radical terms in this equation. We want to separate them. Let's make it so they're both positive. So let's add the fourth root of 2a plus 6 to both sides of the equation. So on the left side, I get the fourth root of 2a plus 6. And on the right side, I get the fourth root of a plus 11. So what are we going to do now to both sides of this equation?
Put them to the power of 4.
Right, put them to the power of 4. So then we get 2a plus 6 equals a plus 11. Okay? Subtract a from both sides. A plus 6 equals 11. Subtract 6. A equals 5. Let's check our work here. So I'm going to take this equation. 0 equals the fourth root of 5 plus 11 minus the fourth root of 2 times 5 plus 6. 0 equals the fourth root of 16 minus the fourth root of 16. Well, the fourth root of 16 is 2, but even if it wasn't, wouldn't the fourth root of 16 minus the fourth root of 16 be 0? So the answer checks, and the solution is correct.
So what happens if the 0 is a different number? How'd the equation to the left be?
Then we're in Math 95. Yeah. Then life gets more complicated, because when you square both sides and you don't just have that radical, it takes a while. You end up actually squaring both sides. Then you isolate the remaining radical. Then you square both sides a second time. It's one of those problems where you want to bring your lunch with you before you start the problem. Okay. So it's doable, but we're not gonna make you folks go through that torture. Okay. Be careful what you ask for, kind of thing. All right. I think
that's why I'm here.
There you go. Okay. Well, I think I've tortured you enough for one day. So again, over the weekend, 9.5, as well as the chapter review. Monday, no class, no Zoom meetings, no office hour. Tuesday, we'll review for the chapter 9 test, which will be on Wednesday. Have a good, safe weekend. Go out and stick your face in the snow, whatever it is you do for entertainment. And I will see you all later.
Thank you.
You're welcome.
Thank you.
You bet. Now, let's see here. Here we go.